Team 2, your time starts now.
We all wonder what will happen to our life. We all wonder what will happen after 100 years. We all wonder what will happen to us the next minute. But have you ever wondered what will happen to our life without these electronic gadgets? And what will happen to them after we utilize? And what will happen to them after they get discarded? Is there any such bin so as to go to the earth, circle and come into our hands again? So this is our problem statement regarding when we were walking across the shop, we noticed a pile of electronic gadgets accumulated in a corner. So when asked upon, they said, we just burn it off, sir, and rest of the things are just dumped in the oceans. So that's the thing which struck us. I would like to say, जब तक सूरज चांद रहेगा, इस धरती पर electronic items चलेंगे. And this is our problem statement regarding the PCB, printed circuit boards, in the sense what and all electronic starting from the AirPods to the complex supercomputers, everywhere the printed circuit boards can be seen. The utilization can be seen, their action can be seen. We can imagine our life without plastic, sir. And we can't even imagine our life without the printed circuit boards. They are the basic two things. The drone flying over there to the me holding my mic, everything consists. So our problem statement is electronic waste, specifically to the PCBs, holding from collections and segregation to economic viability, international trade and dumping, and data security. We would be covering all these things.
So, hello. So here is a solution overview of our problem statement. Starting the first initial stage is where we will have a terminal testing of PCBs. Terminal testing is like the wanted PCBs, like only 2 to 3 components will be good in that, and all the components will be like unwanted. So we'll segregate that. The second process is where PCBs are of different sizes, like 2 cross 2, 3 cross 3, 4 cross 4 and all. After the segregation, we'll send that PCBs to a conveyor belt where we'll have a IR heating system where the PCBs will get heated, and we'll try to segregate the components there. After the conveyor belts process, we'll send that PCBs to corkscrew conveyor, which is a mechanical system where all the components on the PCBs will be segregated easily. After this process, the fifth step of this process, where we'll have many valuable metals in that. So we know that pulverization process, where all the components will be converted into fine powder and all. So we'll convert that components to fine powders, and we'll have a fractional distillation system where, based on the densities of metals like gold, platinum and all, plastics and all, this fractional distillation process takes place, and we'll try to separate the valuable components from that.
So this is the basic technological overview of our prototype. So we'll be using infrared heating. Why? Because we think that whatever PCBs have these resin layers on top of it, it will be melted using IRs. And after that, the segregation of components. So once these PCBs are melted, all those surface mounted devices are loosened up because of heating. So while segregating, all these surface mounted devices are separated from the PCB boards. So we have a naked PCB board, which is either a plastic or a copper, and surface mounted devices. Later on, all these go to the powderizing, or in industrial terms, we call it as pulverizing, where all these separated components from the PCB boards are powderized into a very fine powder. And after that, it goes to the fractional distillation, where all these powders are divided based on density wise. So these are a target audience which we need to cover. First thing is the recyclers. In Bangalore, we have e-Parisara. Recyclers really need a proper method to segregate and powderize all these elements so that we can bring it back to the circular economy. And we have large companies. Well, why large companies? Because we know that electronic waste are generated in most of the service-based companies as well as product-based companies. And we have informal sector, which covers like 85% of the market, but is not recognized by the government since they use very primitive methods to segregate all these components, which is not safe for the human body. And this is our basic workflow, which we wish to achieve. So once this is our recycling unit at the center, where we segregate all the components. So after terminal testing of these PCBs, if any one or two components is, it's replaceable, it will be sent back to the refurbished market, or else it will come to our recycling unit. So whatever the structural parts are there, they will be sent back to the raw material. So when I mean structural parts, it's all these plastic covering and all these structural exoskeletons of the electronic components. And the rest, valuable metals like copper, gold, that is powderized, will be sent back to industries like utensils or wire industries. And this is the business model canvas. So if we come to the key proposition part of here, the transparency that we wish to attain will ensure the stakeholders' trust. Because what happens in this e-waste market is there is lot of things going on, and hence transparency is not that good. And revenue streams, we have second-hand market and companies because we provide raw materials to them, and a valuable metal market as well. So this is the market research. So the total addressable market is around 8.8 billion rupees.
You are on the 6th minute.
So after deploying the model, we come across the piloting issues where we have to connect with the recyclers, the e-waste producers and all. So this will be taken care by AI models, such as we can create a model which can help us connect to those people. And then we'll come to chemical behaviors. As we know that we have hazardous chemicals used in the PCBs for betterment of PCBs, but are hazardous to our health. So while contacting with the PCBs, we have to take care about that, which will be automated by using AI models again and embedded systems, due to which we'll take out the chemical behavior issues. And then we'll come to limited awareness that all of us know that we don't know what's happening with the e-waste here. So we have to have an awareness, or people have to have the awareness of what e-waste will cause to us. So it will be generated by us creating an application in social media platforms and create awareness with promoting our models. And then coming to collection and logistics, we are going to use again the AI models, that is the Digikstra and the shortest path finding models, which will help us to collect the e-waste to our sectors to recycle it or give it to the recycles also.
These are the next milestones that we wish to achieve. First one would be the chemical testing for whatever processes we have proposed. That is the proof of concepting for all the chemical tests that we do, so that this prototype will be viable in the future as well. And next is the piloting. So we have proposed a business model along with our prototype, and once we pilot it over a city like Bengaluru, we'll be sure to get recognition to our prototype. And finally, deploying the user-friendly prototype for a market test.
Do you have anything to say what is the current e-waste management stuff and how it is different, your differential piece?
Right. Okay, so we have contacted a formal recycler here in E-Parisara.
Have you visited multiple e-waste factories?
Yes, like the one recognized by the government is we visited only E-Parisara.
Okay.
And there was another recognized recycler called Zolopic and Scraplan. We have visited a lot of them.
Okay.
But what we found was they use primitive methods. And what we got to know is that whatever PCBs are segregated here, they get sent to third world countries, Taiwan or even Belgium, to extract these metals. Again, these metals are brought back to India. So you can see the a gap there.
You have to mention that. You have to mention the whole point is about how the e-waste management is getting done here. What happens if it becomes a local? Okay, that's the differentiation that you need to bring out.
Indeed.
What do you guys have so far? Is this the idea that you guys have, or do you have some place where you actually have done this? This is just an idea?
This is in the ideation stage. We have reached out to mentors from IISc and for chemical testing, and we have seen proof in research papers.
Mm-hmm.
But yeah, we need to test it chemically to check its viability.
Okay, okay. Do you know what is the cost, capital investment involved for the whole thing?
For basic testing, we have just like 9.7 thousand, like 9,761 for just a very minimal proof of testing. But when we do it in industrial grade, we need around 10.5 lakhs.
Okay.
Hi. So if there's a set of process for this, right? I've been on the solid waste management team of BBMP as well. I also work with Karnataka government. I'm an advisor to the rural water and sanitation and e-waste management, right? So between this whole process, right, there are two parts. One is the collection part. One is the segregation, right? So not segregation, but rather recovery of the materials, right? Segregation happens. Do you know that segregation happens?
Yeah, yeah.
It's not actually a big challenge. As much as it is made out to be, that is not a challenge in terms of collection and segregation. It is actually the recovery of material.
Yeah, right.
That is the toughest part.
Okay.
That's why it hasn't been great success across the country, right? So there is something called as Form B11 that is being given out. So every bulk waste generator has to segregate e-waste at source.
Right.
E-waste gets segregated at source, also at the secondary and tertiary sources, right? So segregation is not an issue, right? I don't want you guys to focus on segregation of the waste. The most important element is to figure out how do you really recover the material, right? That's called as mineral mining or secondary mineral mining, okay? That is what you should be focusing on. That is what your chemical, when there are two established methods. One is the pulverization and distillation method. The other is the chemical recovery,
process.
right? You dip it in certain chemicals, so each of them will attract a certain element in the chemical table that can be taken out. Now, what's more important is not that you need to reinvent the wheel. The most important element here is to figure out the business viability.
Right.
Right? There are existing chemicals that are available. Right? There are factories even in Bangalore. I can name 6 factories in Bangalore that are doing this.
Okay.
There are 6 factories within the city that are doing this, right? At different scales, right? There's a startup called EcoCrew which does collection also. There is government authorized about 22 entities that do these kind of collections, right? They do collections from large corporates, they do collections from household entities, they also do collections from the gated communities. Collection should not be an issue for you. You should figure out how do you make it more economically viable to extract these minerals, right? That is what is the crux of the matter, right? If you can really focus on that and solve for it, making it financially viable for everyone, right? That's when the deal gets made, right? It's not really the collection, it's not really the, even the IR also is not a challenge, right? It's only the final segregation of the minerals is where the challenge is, because you get compounds.
Yeah.
Those compounds are hard to
They are hard
distill
to,
there.
Yep.
And that is where the money is kept, right? I would recommend
We
you
have
to
20
focus on
seconds to close.
Okay, thank you.
Sir, I would like to highlight upon the final stage. After the pulverization, the powders will be passed upon a solution and which undergoes the process called fractional distillation. So based upon that.
Sir, that is textbook answer, sir. I know about it. I'm telling you to focus only on that. Don't worry about all the other bits, right? Because if you can crack that model, that bit, the last bit is where the challenge is. Right now, it is not economically viable. Right? The amount of gold, palladium, or platinum and silver is available in the PCB is very, very minimal. Right? Your cost to extract that is higher than the virgin cost. Right? I can actually mine and get a gold at a much cheaper cost. Right? That is why the recycling is not really taken up across the world, except for few countries where Australia they are doing extremely well. Some parts of Europe they are really good. China is doing that at a mega scale, right? So India really requires this. If you can focus on that part of technology and crack it out, you will be a $1 trillion company, not even a billion. So focus only on that.
Thank you, sir.
Thank you, sir.
Thank you, team.